So, good evening, everyone. Welcome to this 28th pre-lecture. Today, in continuation with the previous lecture, today's lecture is also going to be on agri-waste. We have Professor Sachin from VNIT Nagpur. He's part of the Chemical Engineering Department and former head of the Chemical Engineering Department at VNIT Nagpur. And yes, quite a few publications with a H index of 34 and also about 12 patents. He's also done a lot of sponsored research work, both for the government as well as the industry, and also introduced innovative courses that promote sustainable design to engineering students. With that brief introduction, let me invite Professor Sachin to share his presentation and walk us through the experiences that he had got, largely in terms of converting his research to commercial ventures as well, with the help of his PhD students. So that entire journey would be quite interesting for all of us to know. So welcome, Professor Sachin, over to you.
Yeah, thanks. Thanks, Dr. Sudhir, and I'm thankful to CREI for inviting me on this platform and allowing me to share my experiences. So I'll start sharing my screen. Yeah, so we are working on agricultural waste since last 10 years. And the driving force is creating value for farmers and helping them earning some extra revenue. These are some very interesting numbers. The numbers are about the agricultural waste which is produced. So we converted the agricultural waste into two parts. One is a brown waste. The brown waste is straw and stalk. Any grain that we consume, maybe rice or dal, chapati, right? So for per 1 kg of grain, almost same amount of agricultural waste is produced. They call it as crop residue. On other side, fruit, vegetables, flowers, the horticulture, around 30 to 40% goes waste. The statistics tells me that in India, 50 million metric tons of agricultural residue is produced annually. The idea is creating value from this waste. And the small and marginal farmers generally grow those agricultural produce which are secured by MSP. MSP is minimum support price. And MSP crops are those which produce stock and stocks. So the general schematic of work is followed. We have agricultural waste. Again, it can be a brown waste, stock and stack, or it can be a green waste from horticulture kind of thing. The source can be on the farm or it can be from the food processing industry. So what we do is we have developed the strategy of creating valuable products. Every fruit waste, let it be, I'm going to talk about potatoes, I'm going to talk about oranges, pineapples. So typically those fruits which are available in this part of India. Each fruit is bestowed with some of the other natural compound which is unique in nature. So we developed a method, a technology, which I'm going to share with you, of extracting those bioactive molecules. They are antioxidant in nature, they are nutraceutical in nature. Basically, they are high value products. And we extract dietary fibers, soluble as well as insoluble dietary fibers. These are high value products consumed by human beings. Then the end of life either is compost, which goes into agriculture. So we have agricultural inputs, or it can be feed or fodder, which will be ultimately used for animal consumption. Therefore, the technology that we develop produces products which goes in agriculture, which goes either in agriculture or in veterinary or for food supplements. Once these trials are done, we do modeling and simulation for scaling it up to find out its techno-economical assessment and environmental impact, typically through life cycle assessment. Once that is done, the industrial engineering comes into picture. For that, we are fortunate to have a very strong industrial partner. The students who work in lab, the students who are engaged, were engaged in the trials at veterinary field, at agricultural field, they go to industry, sit with industry people, and do actual scaling up design. In some of the cases, couple of students who are having enterprising attitude get themselves incubated and have their startup. So this is how the flow goes. Now I will go into detail of how exactly we do the how do we tackle the green waste and how do we tackle the brown waste. So this is typically about fruits and vegetables. In case of our fruits and vegetables, we are producing one, nutraceutical, antioxidant. Then these nutraceutical antioxidants find their application either in human consumption or maybe in edible coating or as animal feed. The dietary fiber, they are soluble, insoluble. The insoluble dietary fiber, we found that they are excellent prebiotics for poultry feed. Then the end of life, as we call it, goes into compost or it goes into animal feed. This is a success story about potatoes. It's a merino industry which is at Hapur. Hapur is in West UP, 65 kilometers away from Delhi. They are in the business of contract farming of potatoes and they are in potato flex. So what we have done is the waste which is coming out from the potato processing industry is the starting point for me. Using that, we made arrays of products. I'm going to show a small video clip of this is just a minute or so. This is the starting part. This is the fill, trade right. And from this, we extract fiber and antioxidants. We are working on orange, apple, pomegranate. Couple of things are at commercial level. So those who might be interested, these are useful papers about how exactly separation and selective recovery of nutraceutical antioxidants from peels are done. Just like potato, for apple, for pomegranate, for different fruit peels, we use the same scheme. And the last paper is about the dietary fiber used as a prebiotic. These are some other papers for biogas and dietary fibers only. Now, another case, the first case is about the waste which is coming from the industry. This is on farm. The place from where I'm talking, Nagpur, is known for oranges. Nagpur oranges have GI tag, geographical indicator. They are unique because of the geography, this location. The uniqueness lies in its flavor. So here, this is the case of on-farm orange utilization. Here also, around 30 to 40% oranges go waste because of the untimely rain, poor transportation, unavailability of cold storage. The reasons are multiple. We'll watch this short video.
Sorry, when you play the video, can you reduce the volume of the video because we can't hear you talk over it? Yeah, go ahead.
Okay, fine. That I will do. I will move forward. I will just then tell you what I want to tell. So these are the arrays of products which we met. Fine. So the thing that I was talking about is the extraction of oil. Oil, because these oranges, typically in Nagpur oranges, unlike Brazil oranges. Brazil is world's one of the largest orange producer. The Nagpur oranges, they are fluffy in nature, one, and their size is not uniform. It is basically a table fruit. So peeling of Nagpur oranges is extremely difficult. There is no machine. We tried, but we couldn't find. We ourselves even tried, but we couldn't find. We couldn't even develop it. When we tried it with the woman folk, we found that the unripened oranges, to peel it is extremely difficult. This is a work. Then we observe that the oil glands are available only on the outer surface. And that's the work of one of my PhD scholars. And DST itself came forward and filed a patent for the machine. And then, as far as Nagpur orange oil is concerned, India imports orange oil from Brazil. And India is the world's largest citrus oil consumer. But unfortunately, in this entire region of Vidarbha, there are 13 districts, we do not have the orange extraction from orange peel, orange oil extraction from the peel. There, we found that we need a unique identity. Therefore, we approached to BIS standards and we have filed an application to BIS claiming that this oil is unique since it has been extracted from unique oranges which are GI tag. So kindly treat us differently. Again, it's a part of student work, which we finally approached to ministry and they funded the project. A couple of outcomes. Just sharing the title of the paper so that if somebody wants to know more in detail, we can go through these papers.
Typically, this is where in India, North India, the Haryana, Punjab, West UP, you will find in newspaper in November, December, the issue of stubble burning. The same issue persists in other part also, like in Nagpur, farmers burn cotton stalks. Then we have sugarcane trash. So typically, all these, we call it as biomass having C/N ratio more than 50. This is extremely difficult to degrade and it takes relatively longer time for reducing C/N ratio. The farmers now the what is C/N ratio? C/N ratio is carbon to nitrogen ratio. When C/N ratio is 50 is 20 or below 20, that material is called as composted and it is liable to put into soil. Whereas the residue crop residue which I'm talking about has C/N ratio more than 50. Cotton stalk, it is around 60, 64. Sugarcane trash, it is 70 and more than that. Paddy straw, it is around 50, 52. So it is difficult to degrade. And there where we chip in. This is a work by one of my postdocs and a couple of PhD students. What we have done is we develop a bioculture. There is a short video. The video will talk more in detail about that. And using that culture, we develop a process of making enzyme on farm. Even the farmer can make enzyme. And it can be used for 3 applications. One is for fodder. It improves the milk yield if it is fed to cattle. If it is fed to goat, it improves weight. There is a weight gain. It accelerates composting. Generally, composting of these biomasses takes 3 months to 6 months, whereas the culture that we develop takes 1 month's time. But if the culture and enzyme use both together, the time required is just 15 days. 15 days is relatively too fast. We call it as rapid composting. The initial work of this rapid composting is done during summer internship. Last year, my own student of second year had been to the industry for their summer internship program, and whatever the data, the work that they done, it has now been converted into full-fledged process. Student learn, the industry got benefited. And third is biogas. Mostly for biogas, these agricultural residues are not used as a feedstock. But when we pre-treat the agricultural residue, we achieve following thing. We get enhanced gas production, more gas than usual. Second, we get faster gas, lesser time to produce gas. Third, we get enriched gas. We get more of a methane. This is a part of PhD work as well as internship work. We are closely working with Merino industry. We are closely working with Merino, which is the outfit of NDDB. NDDB is National Dairy Development Board, the apex body of Mother Dairy and Amul. So they are helping us in field trials for cattle. They are helping us in biogas, where along with the cow dung, we will be using the crop residue. This is the video which will talk more in detail.
In a laudable industry academic collaborative venture, Merino, along with the Energy and Resource Institute and the Vishweshwaraya National Institute of Technology, Nagpur, has adopted a cost-effective method to convert paddy and other agro-waste into a soil-enriching compost. This is an environmentally friendly alternative to stubble burning. Large quantities of paddy straw is collected from in and around Hapur and stored in sheds. It is then reduced in size by a pulverizer. After this, the shredded and crushed paddy straws are fed into a ribbon tray, where the patented bioculture is sprayed into them and it undergoes dry digestion.
Merino Innovation Center has come up with a unique culture, a biodigester, which digests paddy straw in as less as 3 weeks' time, which otherwise takes 3 months to 6 months. And the product is patented. Not only so, the product has commercialized with a title as Bajrang Band. So Bajrang Band is a very unique decomposer, microbiological consortium, which is used for rapid composting of paddy straw, which we can do as a centralized facility like what we are doing here in Merino. On a pilot level, 1 ton of paddy straw on a daily basis is being composted.
is being digested, which we are now scaling up to 15 tons per day.
The primary aim of the patented bioculture is to tackle this huge problem of bio-waste and its fruitful dispensation. It is aptly named as the Bajrang Barn. The mixture is then collected and stored in plastic bags, which themselves act as an anaerobic digester. With the help of the microbes
Sachin,
in the Bajrang
do
Barn,
you
these
mind
shredded
if I
paddy
ask a
straws
question?
get decomposed in 21 days.
Yeah.
Okay. So if you can give us some quantification of and possibly some economic dimension of these processes, that would be extremely helpful. For example, if we could know from 1 acre of stubble from a particular crop, how much compost could be made and how much nutrients could be returned to the soil for how much area, and what is the cost, labor cost, and any other costs involved, either at this stage or at later stage. It would be great if you could give us some quantified ideas about the quantities involved and the economics of these, not necessarily at this point, but at some point in the talk. Thank you.
Thanks. I have a slide later answering all of your questions. I am put one slide. We'll complete the video and we'll move the slide then. I will try to answer the question.
Then is an organic manure for agro use. The process is simple, but the result is a remarkable alternative to a major environmental problem. Professor Sachin Mandavgane tells us of the meaningful and valuable collaboration that Visvesvaraya National Institute of Technology has with Merino Industries.
VNIT, Visvesvaraya National Institute of Technology, and Merino Industries, we enter into an MOU, and as a part of that, VNIT is having Merino Innovation Center. In that innovation center, we are taking up different projects under the sustainability related topics. The lab work, typically we call it as development of proof of concept. The proof of concept is developed in VNIT laboratories. MTech students, PhD students, even the undergraduate student work on these topics. Once the proof of concept is established, then for scaled up study, for a pilot plant study, we come to Merino. So the understanding is following. The basic laboratory work, basic experimental work, which I would be doing maybe in 100 grams or 500 grams of quantity, is done in VNIT. We develop the proof of concept, we develop material balance, energy balance, general understanding. Once that is done, when I have to go for maybe 10 kg, maybe 15 kg, 50 kg of material, we call it as a lab plus experiments. So those lab plus experiments are carried at Merino campus, where students who work in the laboratory, they themselves come here. So now they get the exposure of industry, and we carry out the lab plus experiments. Once the lab plus experiment are successful, we go for a pilot plant, where the couple of students are having their PhD topic around this. So they are doing their PhD as well as they are solving a real life problem. So instead of solving an unsolved problem, the students are working on the problem for which the solution is needed.
This is typically a scientific data where how exactly with the help of enzyme, T2 is a batch with enzymatic pre-treatment, and the duration for composting is just 15 days. Otherwise, with Bajrang Band, it is 30 days. Even 30 days is relatively less compared to the conventional one. This is what is being done at Merino right now. They are producing 2 tons per day. And based on this, CII Foundation at Haryana, Sirsa, they installed this plant, and at Barnala also, the plant installation and commissioning of plant is underway. Now, coming to biogas, so I will just pass through this, and we have a slide at the end about all economics. This is about biogas. Generally, cow dung is used, or maybe kitchen waste or municipal solid waste. Here, what we have done is, along with cow dung, we are adding enzyme treated paddy dung, enzyme treated paddy straw, to which we call it as a paddy dung. It's not a scientific word, but the paddy dung resembles very close to cow dung. And when both are fed, we found that the methane content is not less than 65%, and carbon dioxide content is not more than 35%. And the interesting part is, if I feed 100 kgs of cow dung, I would get 4 meter cube of gas. Now, in this reactor, it's a 6 meter cube, relatively good size industrial reactor. We are feeding 125 kgs of paddy dung and cow dung combination. Had I used only cow dung, 125 kgs of cow dung, I would have got 5 meter cube of gas. But with the combination of paddy dung and cow dung, I'm getting 8 meter cube of gas. These are the trials which are going on since March 2023. So we have a data of almost 1 year. And fine, I will move forward. Then this is about use of enzyme treated crop residue as a fodder. So we tried it on cattle. We thankful to NDDB because they help us in carrying out the entire trials. We merely provided the enzyme, and my scholar did enzyme characterization, synthesis, and he was there on the farm while carrying out this trial for 90 days. Standard procedure for field trial were adopted, and we found that the trial started on 4th of November 2023, and there is an increase in milk yield by 5%. Generally, if the milk yield is increased, it is at the cost of fat, but unlike that, here even the fat is increased. So NDDB is willing to launch this enzyme on 27th of April, which is World Veterinary Day. We work on goats. Maharashtra's veterinary university is in Nagpur. So they did it on small ruminant like goat. Here, instead of milk, their objective was increase in weight. So when enzyme treated cotton stalk, in case of cattle, we fed enzyme treated paddy straw. Here we fed enzyme treated cotton stalk, and we found that there is a weight gain of 5%. Yeah, these are the numbers. So the numbers are following. I will answer the first question, which is not listed here, but which has been asked. 1 acre of land produces around 2 tons of crop residue. It may vary from 1.5 to 2, but let us take 2 tons of crop residue. This 2 tons of crop residue has 7 to 8% of moisture. When I convert it into compost, the compost should have moisture content of 40%, 40%. So if I take 1 acre of land with 2 tons of agricultural waste, that 2 multiplied by 1.4 is something that I produce. Let me see how much is that. 2 multiplied by 1.4, around 2.8. So the compost which is produced is around 2.8. Now, as far as the culture is concerned, the cost of culture is 60 to 75% per kg of agricultural residue treated. It means that if I am for 2 tons, I'm treating 2 tons, I will be producing around 2.8 tons because I'm adding moisture. Then in that case, per kg of compost produced, the culture cost is around 30 to 40 paise. We have two types of compost. One is a base compost. What is base compost? Base compost is where I have shredded the agricultural residue, I put it into the ribbon mixer, or I merely sprayed the culture over it, allowed it for 15 days for incubation, and I get the compost. That including electricity and labor cost, somewhere varying between 1.5 to 2 rupees, 2.5 rupees per kg. A farmer can sell it somewhere at around 4 rupees or 5 rupees. This is the base compost. We are fortifying the base compost. The fortification is done by adding some organic nitrogen source, organic potash source. I'm going to talk about the potash source as well. So that compost, the cost of that compost varies somewhere between 5 to 7 rupees based on what are all the things that we are adding for fortification. We call it as sanction and in sanction. We add different types of organic culture, different types of cultures to improve the quality of compost. We add potash, we add phosphorus source, we add nitrogen source, so that the fortification is done. Then coming to biogas. For biogas, I required enzyme. If the enzyme is produced on the farm, then the cost per liter is because it all depends on the labor and the volume at which the farmers is going to produce. So on an average, it is 5 rupees to 8 rupees. But NDDB asks us that the farmer may not be willing to produce enzyme of his or her own. So come up with your own product. So we are now coming up with a concentrated product with a profit, and we are told that the cost should not be more than 50 paise per kg of feed fed. So the last line I'm reading, cattle typically fed 10 kgs of fodder per day. So he will have to have extra 5 rupees to shell, because 50 paise per kg for 10 kgs, 5 rupees. Cattle, Indian cows, on which we tested the Gir cow, the average milk yield is 10 to 12 liters per day per cow. There we found that average increase in milk yield is 500 ml, half liter. So half liter costs somewhere between 15 to 17 rupees, because farmers sell milk at 35 to 37 rupees based on the milk federation. So half liter, the value of half liter is around 15 to 17 rupees. So for that extra 15 to 17 rupees, the investment he has is of 5 rupees. That is what enzyme. As far as the biogas is concerned, we get, as I was mentioning, that instead of 5 meter cube of gas, we are getting 8 meter cube of gas. The more gas, around 40 to 50% motor gas, the HRT is less, 15 days to 20 days. And HRT is because that decides the volume of the reactor. Conventional process has HRT 25 to 30, whereas in our case, it is around 15 to 20. And moreover, the methane content is relatively good, not bad, around 65%. So these are the numbers. Now coming to biopotash, I will just run through I will just run about video so that I need not to talk much.
These days, chemical process industries are using biomass like paddy straw, biomass briquettes made from cotton stack, soybean stack as a source of fuel. When it is burned in furnaces and boilers, ash is produced. This ash is a rich source of potash. We can use this ash back to the soil and check its effect on the soil health and
uptake of the plant. This is the idea we propose to BRNS. BRNS sanctioned this proposal, and as a part of BRNS project, we are working on use of biomass ash in soil health and plant nutrient uptake. We have collected this biomass ash from an industry near Nagpur. Butibori is the industrial area. This industry uses biomass briquette as a source of fuel, and the ash is produced 3 tons per day. Now, this ash, when we collect it, we characterize it, we did detailed analysis, and we found that it's rich with potash as well. Now, if I want to make use of this in soil, I need to make granules. Making granules of this ash is a challenge because of the nature of the ash. It doesn't have binding capacity. Therefore, we were looking for some binders such that it is compatible with the biomass ash. At the same time, it adds value. Out of different binders that we tried, we come across compost. This compost is made from paddy straw. We made the compost, dried it, and then pulverized it. We tried different permutation and combinations of proportions for using biomass ash and compost. We found that 50-50 is the optimum ratio in which we can use compost and biomass ash. When these two things are properly mixed, they combine together and provide a better binding capacity. We are able to make granules using this formulation. In this formulation, we have added binders. Now, once we have this method, a process of making granules using biomass ash, we can make granules as per our requirement. Means we can fortify and enrich the granules using maybe calcium rich granules, maybe silica rich granules, and thus we can have granules of different composition and formulations. We can produce granules using biomass ash and compost of desired diameter. We can tailor the diameter based on the requirement. The maximum diameter that we achieve is around 6. The minimum diameter that we achieved is 2. 4 millimeter is the recommended diameter as far as FCO is concerned. When biomass ash granules are used for experimental trials in private farms, it is found that the soil health and plant nutrient uptake are improved.
Almost done. And these are a couple of papers about biomass ash used in agriculture and its characterization. Yeah, we are working. This is whatever I spoke is all about the experimental work. Apart from that, for every process that we develop, we do detailed life cycle assessment, we do techno-economical analysis, and there are a couple of frameworks that we develop using emergy, that is leaf, and we try to find out the sustainability index. Based on this, recently, Department of Science and Technology has awarded us one Center of Excellence. We call it as SWAHA. So SWAHA stands for, S stands for Sustainability Assessment, W for Waste Valorization, A Agricultural Inputs, H for Health Supplement, and A about Awareness and Training. We are developing short courses on biorefinery and agricultural waste utilization because we require a manpower who knows little bit of biology, little bit of engineering, little bit of veterinary, little bit of agriculture. So biogas production, microbiology. So such kind of skills are required, and therefore we are now working for developing the credit course, not credit course, but the certificate course. And in this COE, we have collaboration, we have partners, Veterinary University of Maharashtra, IIM Nagpur, we have AIMS also in Nagpur, then JNU's Center for Science Policy, and IARI, Delhi, for agriculture related work. So thanks a lot. I'm done as far as the presentation part is concerned. Open for question answer.
Thank you, Professor Sachin, for an excellent talk. Now I'll open the forum for questions from any of the participants.
Thank you very much. That was really very good presentation. I really enjoyed it. One of the questions that comes to my mind, because you're doing this in a very decentralized manner, nearer to the farm, closer to industries and farm, and so on. Okay. So the question is, if you were to scale it to other parts of the country, can you get an estimate of the kind, like you talked about Brazil citrus soil, so you're also talking about import substitution and substitution of chemical fertilizers versus biofertilizers, as I call it. Do you have a sense of how much of this, how much waste is generated, in an Indian context as a whole in different agricultural products? Do you think we could substitute a whole bunch of chemical fertilizers in the long run? Maybe 50%, maybe 30%, maybe 50, 60% of chemical fertilizers can be substituted with this biofertilizers and compost and so on. Do you have a sense of that? Because it has a national level economic implications, right? Beyond the farm.
May I add a supplement to Sub's question, please, because closely related. The good part of bio waste generated in the field is left in the field to create mulch, and separate processing of that mulch waste into this form will, of course, bring the nutrients back to the field, to the soil, but it will deprive the soil of what would have been added by natural decomposition of the waste in the field. So is the addition being counted from this bio-waste processing is gross addition or net addition after subtracting the loss of natural decomposition in the soil of the waste product left in the field?
Yeah. So I will try to answer both the questions. The first part is about the sense of total waste. So it says that 50 million metric ton is the agricultural waste which is available. And as far as substitution is concerned, that's a very tricky thing. And I strongly believe that as far as the nutrient requirements are concerned, the amount of N, amount of P, amount of K, and other micronutrient required for crop, because post Green Revolution, the nutrient requirement of each crop is very properly standardized, and those numbers are there. Without compromising the nutrient requirement, the one possibility that we are exploring right now with one of the industries is partial substitution. And two things we are keeping in mind. One is without compromising the final yield, and second, without compromising the nutrient requirement of the plant. And in that case, proper combination such that source of carbon is maybe compost,
we have another source of nitrogen which we are trying from fungi. Then potash is from biomass ash. So making a proper combination such that 100% replacement or 50% replacement, I think that's a very dangerous thing, which unfortunately Sri Lanka did suddenly, and it collapsed. So answering the question one, 50 million metric ton is the number on record, but that number might be more than that. One. Second thing is, instead of complete replacement, there can be a proper combination of agricultural waste, chemical fertilizer, and agricultural input such that the final yield is not compromised. And third thing is, compost to begin with can be used as a carbon sink, and secondly, to increase overall microbial population in the soil. So that is the, as on date, that's the answer. And answering the second part about second part, I forgot the question.
What is the difference between natural decomposition?
Yeah,
and
mulching.
replenishing the soil?
Mulching. Yeah, got it. See, ideally, farmers should go for mulching. But now what has happened that farmers are going for 2 crops, and in some cases even for 3 crops. Typical reason for stubble burning in North India is in the end of October or first week of November, the paddy has to be harvested, and their next crop is at the end of November or in the first week of December. The farmer has just 4 weeks time, and in that 4 weeks time, the easiest option the farmer find is burning it. So our option, wherever the mulching long duration crops are there, farmers are still doing mulching. Mulching is anyway recommended. But when the farmers are burning it, instead of burning, we are finding out the solution for that. And that too on the farm itself. And that too in a short period. Because the entire, the gist of the matter is timeline. They want a solution such that within 2 to 3 weeks, the agricultural residue, agricultural waste is taken care of. And there where, when we work on enzyme, when we work on this Bajrang culture, we kept the time factor in mind. But anyway, mulching is the solution as a natural part. But farmers are not doing that. But obvious reasons are
there. So from what you are saying, even they are not doing that, but mulching is the best solution for them to adopt. By using this, at least you are able to recover some of the nutrients and other things to be fed back to the farm. That's your argument. Yeah. But in order to do that, you want to make sure that the composition of the nutrients that are generated by mulching is also is somehow created through this composition process of enzymes and other things which you have generated. Is that correct?
No.
That balance has to be created, no?
No. That is not what I want to say. I'm saying that mulching takes more time. It's a longer time, right? And mulching is like whatever agricultural residue, I keep it back. Naturally, it will decompose. It will become part of soil. That is one. That is one part of the story, right? The two things which I want to mention is that, for example, I am a farmer and I am growing paddy straw. For paddy straw, for cultivation of paddy, there is a recommended dose. They call it as RDF, recommended dose of fertilizer. That recommended dose of fertilizer will tell me that you use so much of nitrogen, you use so much of potash, you use so much of phosphorus. So NPK should be used so much. Then the micronutrient should be used so much, right? So there are some standard numbers which IARI or Indian Agriculture Research Institute, that is available in public domain. How much for each crop, what is the nutrient requirement? the point I'm making is answering your question that can we replace the chemical fertilizer? I'm saying that replacing chemical fertilizer suddenly is not possible. It should be done keeping in mind that the nutrient requirement of the crop is met by different sources, and one of the source will be compost.
Mm-hmm.
And second part of the question about what I was asked, mulching. See, if we can create value, if we can create value in a sense that if I can make a good quality compost, a fortified compost, the farmer can get some additional revenue from that.
Mm.
So the idea is not only about replacement for stubble burning. The idea is about producing making a product which is sellable.
Thank you. Go ahead.
Yeah, I have one question, which is more in terms of given that this kind of problem exists across several parts of the country, how does this technology actually reach to the different stakeholders? Is it through, like, for example, the company that you are partnering with, they may have a limitation in terms of the number of pilots that they can create or the number of plants that they can create. But if the IP is connected to between you and the company, how does it help in proliferating this across the country? Are there any issues around that?
Yeah. See, I was invited by additional chief secretary of Maharashtra government agriculture, and because this is a very common problem related to agricultural waste and creating value. So our proposition is following, because as you rightly mentioned, the IP is with us and the industry, right? So the heart of entire technology is the culture and the enzyme. So we are proposing, I mean, a couple of my research scholars, they are interested to have their own startup, so that either the startup or the industry, because startup has its own limitation and they do not have that, I should say, wisdom of manufacturing. So the research scholar will produce culture and enzyme on the industry side. Once that is done, as far as requirements of machineries are concerned, one story is about CII. CII Foundation. CII is Confederation of Indian Industries. So they, through CSR, are installing machines, because the investment is about machines. Culture is provided by us. The machine will be provided. So we are looking for partners who will provide machine. When we were talking with Maharashtra government secretary, he said that we are ready to support for machine, because for them supporting machine is easy, because they want to support which is uh, tangible, like machines. So you give machine for 1 lakh rupees, 50,000 rupees, or subsidy for that, something like that.
So the point is, are you saying that it is probably corporate sponsored or government supported facilities to be created in different locations, or can it be a private enterprise by itself? Why can't smaller companies take the license and then do it?
Obviously, we are open for that. Yes. Yes.
No, but is it economically viable for them to set up a plant and process this kind of thing?
See, here, no. Here, the real product is enzyme. The real product is the culture. Rest of the things are not very unique. Biogas plant, anyway, if you have a biogas plant, in your biogas plant, if you are using cow dung, I'm saying that along with the cow dung, you use crop residue. So the facility is with you. Only thing that you require is culture. Anyway, farmers are feeding fodder. So to that, just add a little bit of enzyme. So that's the idea. So the issue is about the transportation and supply chain of culture and enzyme. And that is where we are trying to sort out the issue. Otherwise, as far as the machineries are concerned, so existing setups can be used.
Yeah, that is true. But strategically speaking, the value in the end product may be far higher, right? So your enzyme may be pretty cheap. So it is like what you said, 20 paisa, 60 paisa, right? And if an entity sells only the enzyme, but the real value comes with the downstream product, right? So it might actually make sense for somebody to own that entire process and build it. Then only they can extract value from that. So there
That's the
may be
more
a challenge
that
in
is the
the
most
way.
ideal situation.
No, that's why one side is if I have a company which is just manufacturing and selling the enzyme, and institute say has an IP for that enzyme, you outsource that IP or you license that IP, somebody manufactures and sells it, right? But clearly at the farmer level, if they just buy the enzyme and use it, there is some kind of value. But if they have somebody who can manufacture this, process this, maybe the value is higher in that kind of case. So exploring different business models may be an thing to look at here. That's what I feel.
Sure. I mean, please guide us on this. I mean, we are open for listening and some guidance on this area.
Sure. So any other questions from the participants? We have come to the close of the session. Okay. There are no more questions. Then Sub, can you announce the next talk?
The next talk is by Professor Barbara Oakley from Barbara Oakley she's a distinguished professor of engineering at Oakland University in Rochester, Michigan, and the title of the talk is Using Generative AI to Strengthen and Speed Learning. She's an engineer. She works on the area between complex relationship between neuroscience and social behavior.
Thank you. So thank you, Professor Sachin. Thank
you.
Sorry,
there's somebody. Okay. No.
Ask Professor Sachin to say a few words about teaching.
Yeah. And educational implications of your students and so on, which we discussed earlier.
Yeah, I will tell you. I teach 2 courses which are directly helpful in both the ways. I mean, the courses are helping me in research and the research is helping the students as well. I take a course on sustainable engineering. It's a credit course, complete semester credit course. And second is about engineering economics, plant design and engineering economics. All these are project-based courses. In case of sustainable engineering, the course has games, the course has debate, the course, lastly, the student has to take up a project for decarbonization or a journey of net zero of a process plant. And there, for example, say production of ethanol, production of styrene, take any chemical, we have listed a couple of chemicals, and student will first find out the CO2 emission as is, then they will come up with new technologies, some interventions where the carbon dioxide mitigation is possible, and then finally CO2 trade-offs. So how much is the money? So the answer of the project, the final present of the student finally has to tell that the rupees or the investment per kg of CO2 reduction, and maybe the journey of decarbonization will be 10 years, 20 years. It's more of a real life situation and student actually come up with an industrial solution. That is one. Secondly, I teach a course called fluid mechanics, and I did some experiment that is pre-COVID. Post-COVID, I couldn't. And it's about role of fluid mechanics in day-to-day life. The student has to make a short video based on whatever he learned in class, and only condition of the video is that one of the team member must appear in the video and there should be a voiceover, and each student will get same marks, but all these videos will be posted on Facebook and it will be tagged to me. Now the student will not to worry about the marks because everybody will get equal mark. They should worry about good comments. They should worry about, they should strive for excellence. Then I have another assignment called Fun with Fluid. The Fun with Fluid is an assignment in lab. Again, this is pre-COVID.
Right.
And about Fun with Fluid. Fun with Fluid is something interesting. It has 4 verticals. The first vertical is frugal lab. Frugal lab means using the resources which are available in the hostel, maybe in the lab. He should demonstrate the principle of fluid mechanics. Here, the objective is not the accuracy. The objective is, can you demonstrate the fundamentals? That is frugal. So a student has to choose any one of that. Second is PowerPoint presentation. But the PowerPoint presentation should be such that you have to teach a course, a topic of fluid mechanics to non-fluid mechanics, non-chemical engineering student. So accordingly, you have to make a presentation. Third is poster making. Poster making here, the conclusion of the poster should be a question. You might be knowing that we have stories of Vikram Vetal. In Vikram Vetal, there is a story, and at the end, the Vetal will ask a question. Similarly, here, student based on the real life, he has to make a poster, and at the end, he should come up with a question. Like student come up very interesting posters related to disasters and accidents in chemical industry and how exactly the fluid mechanics played a role. So that is third. And fourth is some amusement related to fluid mechanics. So either of this, the student has to choose and he has to present, he has to make a video. So we have a YouTube channel, Students Innovate. And in that Students Innovate, all these Fun with Fluid related editions are posted. But unfortunately, post-COVID, I couldn't do much.
What do you, just follow on a couple of minutes, on what do you see student enthusiasm for engineering go up and the understanding that they have a very clear role as an engineer they can play in society? Does that consciousness come out of this kind of efforts you are doing, and do you evaluate it in some fashion by interviewing the students or doing surveys about their learning, which could also be very useful in thinking about the effectiveness of these programs and student participation enthusiasm?
That I did. About the cases which I shared, I did some survey, I did impact study, and I published paper just to understand about this. One paper is your American Society of Engineering Education has chemical engineering education. There I published a paper about this Facebook related activity and about this Fun with Fluid also, Journal of Education, Chemical Engineering Education, something like that. I'm not exactly recalling it, but I will share both the papers with you. And there I tried doing survey and impact study and students feedback. And overall, I found that because the sustainability is a elective course. So, and every year the registration is around 60 students, 70 students. Students are enthusiastic for taking this course because I found that if the student can relate the classroom teaching with the real life, they get excited. One. Second thing is about they want some kind of unorthodox, unconventional assignments. I will, for example, we in sustainability, we have a role play. Role play in a sense that we have listed 8 different topics. Let us take one topic of Sri Lanka is one of the topics. The way Sri Lanka adopted agriculture, right? So the role plays are following. One would be politician, one would be a policymaker, one would be executor, one will be a common man. And then we have this Indonesia burning of peat forest. Because of the peat forest, then we have this. There are a couple of issues. Like in Maharashtra, we have Latur drought, a very serious issue as far as the sustainability is concerned. So we picked up such topics, maybe from India. Deforestation in Amazon, another topic. But the objective is one topic. Look at the topic from different perspective. Let us have a very balanced view. Let us not be activist, right? Only activist, because what the farmers think, what the politician thinks, what the control, your CPCB, like pollution control board, is saying. Look, thinking from wear everybody's shoes and have a presentation. So role play is very fun. I mean, everybody enjoy it. A lot of debate. They will have very strong views, something like that. So
Thank you very much.
I strongly believe that the quality of the course depends on the quality of assignment. Now, because of MOOCs and everything, students have so many options of learning. I keep telling my student, you don't worry about whether I teach good or bad. You learn, you have so many sources, you have so many MOOCs platform, you learn from anywhere. Attend classes for assignment. So I spend more time in developing assignment and thinking over it. Thanks, I'm done.
Thank you. So thank you, Professor Sachin, for an excellent talk and also very detailed elaboration on the teaching experiments. I think that will be a separate talk by itself if we arrange it at some point of time. So thank you again for joining us, and thank you all the participants. Look forward for the next talk, which will be on 1st May. Over to you, Sab.
I will also join it. Thanks a lot.
Yeah. Thank you. And all of you have a very good evening, day, whatever part of the world you are in.
If you are interested in a talk, please contact us.
Yeah. Okay.
Thank you. Thanks a lot.
Thank you.
Bye. Bye. Thanks a lot.